will be taking us through uh, matter and materials. And without wasting any time, maybe as it hold, thank you very much. Feel free, ma'am, to enjoy yourself. And remember, ladies and gentlemen, kindly complete the register that was sent with the link, as well as we are recording it or streaming it live on our YouTube channel. So it will be available later for you to watch and maybe share with your learners if they are unable to watch. Ladies and gentlemen, thank you very much for being here. May the Zidin hold all the best, man.
Thank you so much, Mr. Nambani. Good afternoon to everybody watching us from all over. I hope that you also enjoyed yesterday's election day, and I encourage you to look into yourself and build yourself so that you can one day lead us as the first technical science student that will be the president of our country. So let's vote for digital learning and vote for level 7 in this exam. Right, let's start. So the part that I'm going to be dealing with today is matter and materials, which is counting 40 marks out of 150. And we have two segments. So we've got the part for 10 marks, and then we've got the part for 30 marks, which I'm going to be dealing with separately in this lesson. Right, so, sorry, the 10 marks is your matter and materials, a part of the nature of a specific material that is usually given to you in the exam. So here we are going to look at all the different properties of a specific substance or a specific material. Right, so let's start there. Right, so when we look at the periodic table, essentially what we are looking at is we are looking at three components, which I have here as red, yellow, and blue. Sorry if you're colorblind, but basically I'm talking about this area on the left-hand side, then the step here starting from boron, and then from carbon on this side, on the very right-hand side is your non-metals. So the first classification that we speak about is whether a material is a metal, a non-metal, or a metalloid. So all of these ones here, except now for hydrogen, pencil, right? Except now for your hydrogen, but all of these here, we classify them as metals. And that's going to become important because of the virtue of the fact that it's a metal, it will behave in a certain way. And because of it being a non-metal, it's also going to have its own characteristics. So it becomes easy. These ones are all metals here, the red ones. Then these ones are non-metals, which we usually associate with the fact that, okay, they are gases. For example, if we speak about oxygen here, we know that oxygen is a gas that we find, in the air. Then we also know that these ones are also then our gases, which we are then referring to halogens, and you're going to use a lot of these as you go forward in grade 11 and grade 12. So the ones here that are sort of on this step here, we are saying that they are metalloids, which means that they have properties of metals and non-metals, but it depends on the specific element that you're talking about. Sometimes it behaves more like a metal under certain circumstances, and sometimes it behaves more as a non-metal. It depends on what stress it is being exposed to. So I think this is easy. It's from grade 8, 9, even when you were younger. So the red ones here are all metals, and we're going to be looking at the nature of those metals. Then here we have our gases, our halogens, our noble gases. These are gases over here, carbon. Carbon is not necessarily a gas, right? It's also found, for example, in diamond form. So we're just classifying these ones as non-metals, and then these yellow ones here are in between that of a metal and a non-metal, a metal and a non-metal, right? So let's move on. So we already now know the three characteristics: metals, non-metals, and semi-metals. But also we speak about the properties of different kinds of elements or materials. So I'm going to write them in these boxes. For example, the first property we can speak about is the substance brittle? right? That is a property of a material. The next one, we can speak about it being ductile. What does that mean, and how will you know if it, or how can you imagine if it is ductile or not? The next one we speak about is malleability. So we are saying, is it malleable, right? So brittle, ductile, malleable. Then we go into the other ones, which I want to, the fourth one here, I actually want to call it more like physical properties, which will, for example, be aspects of boiling point or melting point. Right, then the next one you can speak about is its magnetism or magnetic nature. Is it magnetic or non-magnetic? Right, and then we speak about its conductivity, right? Conductivity. So we have two different kinds of conductivities. The one is its thermal conductivity, which you will use in grade 11 in thermodynamics. And most popular, we speak about its electrical conductivity. So magnetic, and let me also put non-magnetic. So these are all the properties that you need to be able to know about different materials. You'll even see if you're reading the CAPS document, they say that you need to be able to apply these even to appliances and objects, for example, right? So let's just on the same slide also just add on, what do we mean? So what do we mean when we speak about something that is brittle, right? When we speak about brittleness, it's basically describing this property of a material, saying that it fractures or it breaks easily, right? So it breaks easily. And if you're in grade 12, you'd say, it deforms easily, right? When it's been stressed out. So when you take something and you drop it, for example, and it breaks easily, we will then describe it as, being brittle. If we look at ductility, right, we're basically saying this is a specific property of what? It is now a property of a metal, right? And what is that property of the metal? I'm saying that if I'm saying something is ductile, I'm saying that it can be stretched into a wire. Stretched into a wire or thin rod, right? So you'll see the difference between ductility and malleability. Now, when I'm saying malleability, or if something is malleable, I'm saying that yes, it can also be stretched, but in this sense, we are specifically speaking about it being able to be, I don't know if I should use the word made into or changed, but it's basically when you can form a thin sheet from it. And that sheet, you can use it for different things. For example, the door of a car, or you can cut out circles from it, maybe forming coins, whatever it is. So both of them are subjected to some sort of stress, but ductility is where it forms into a wire or rod. Malleability is when it's a flat sheet that you can use, for example, the roof of a house, the side of the car, doors, or something along those lines. You can still then make or cut out, make tins out of it, stuff like that, okay? Then the others are easy now. When it comes to thermal conductivity, thermal means heat. So that is the ability of that object to conduct heat, right? Because we call them insulators and some we call them conductors. So something can insulate you from heat like a sleeping bag, and others will conduct heat like a pot, for example. Right, and then electrical conductivity, that is obviously electrical current, right? So that means that it allows current to pass through it. And then if it's magnetic, it means that it can be attracted by a magnet, right? And if it's non-magnetic, then obviously it cannot feel that force or be affected by that force. So these are the properties, a nice little mind map for you that you can use anytime. These are all the properties that you are expected to know. Right, so let's get started then into using them in examples. Right, so brittle materials. If we speak about brittle materials, remember I said it can break easily, it can fracture, it can be deformed very easily if you drop it or even if you heat it with something. So under here, I've got my first 4 examples. For example, diamond is brittle, glass is brittle, a brick, yes, if you drop them, they can break, and an eggshell is a very good example. And yeah, some woods are also very brittle, especially your chipboard, porcelain, the chalks on the that you use or the teachers use, and then also most salts like sodium chloride is also brittle, right? You can have it clumped together, and the moment you can use even your fingers to break it apart, right? Then this here is gold. Gold is one of the easiest or the most malleable element. Actually, indium is, but we don't go that far in the periodic table. So gold, this is a good example. So this is maybe a gold tray. So that is also the idea that it can be hammered into a sheet. So this is gold, it's being hammered, and then you get a sheet, which means that it is malleable, because malleability means it can be formed into a sheet. Right, the next example that I have here is copper metal. So you can see also this copper can be stretched to form the copper wire. So a copper wire or rod, it's round in nature. This is ductility, right? So that is a good idea of how to remember anything that is in a form of a wire. Remember, you get different kinds of wires, not only copper wire. So those are ductile, and then stuff that you can make, like especially decorations in the household, those are basically malleable. So you can just check for yourself examples while you're studying. Right. Then conductors of electricity. So by definition, we're saying that it's any material that allows electricity to pass through them. And insulators are then those that do not allow electricity to pass through them. So examples, your metals, some salt solutions, for example, we call them electrolytes in grade 12. Carbon as well, there's graphite in the pencil, so you can use a pencil also to complete a circuit. Your insulators don't allow electricity, so most of the non-metals, plastic, rubber, air, and yes, pure water as well. You need other ions for the water to pass electricity. So here's an example of a circuit setup, right? So if you put your conductor here, this bulb should light up. And if you put an insulator here, then this bulb will not light up. So I want to do a FET simulation just for a few minutes to show you like an experiment, because you can also speak about independent and dependent variables with using these examples, right? So here is now my FET simulation. You can also ask your teacher to use this website, FET Colorado Edu Simulations. So I'm going to take out a battery. So I'll put that on that side. I'll take a battery out. This wire is what now? It is ductile, and it is a conductor of electricity, okay? Then I will put another wire over here, connect, right? I can put a switch if I like. I can put another wire. Then I need a bulb, obviously, because we want to replicate that circuit, which is basically saying that if it is a conductor, then the bulb should light up, or glow is the correct word. And then I'm going to leave this open space here. I've seen a past paper before where they put X here, and then they ask, what is the purpose of X? That is where I'm going to put in now the different materials to check, are they conducting electricity or not, okay? So let's just test if our circuit actually works. Yes, it does work. And then we can just break it apart there. So we have checked if all our systems are in place. And now we can choose some of these. So a paper clip. right? Let me go for a dollar bill, a coin, right? An eraser, and then a pencil. Right, so now let's check now this stainless steel paper clip. It is a conductor, right? So it's a conductor, that is a paper clip. It's a metal. It's usually made out of steel, and steel is made up of copper and chromium. Right, here's a pencil. It's also a conductor. You can compare the brightness is a bit less. And what is the conductor in the pencil? It is the graphite there, right? Graphite is a good conductor. Right, eraser is made out of rubber. Rubber is an insulator, no electricity there. The bulb is not glowing. Money makes the world go round. No, not in this situation. Right, it's made out of cotton, or some countries even have a bit of plastic. And this is a coin, so that is a conductor, right? So this is a very easy experiment to do. In this experiment, the the independent variable is the one that we chose. So we chose all of these materials. And what is the dependent variable? The dependent variable is their ability, whether they are electrical conductors or not. So the ability to conduct electricity. And we could have even gone into more detail. I measured the current and all of that. But I just wanted to show you that this is a good way also for an examiner to assess this question. Right. So I just wanted to go back. Oh no, it's actually not back, it's forward. So right now what we done a brief experiment. I just want to add it here. We done our experiment. And in this experiment, right, this part here, remember we were choosing them. So this was our independent variable. And that was the materials that we chose, because we chose all of those materials, right? And then the dependent variable was what we were testing. So the independent variable there was whether this light was glowing or not, right? So if we put an ammeter there, it would have been the reading on the ammeter. Right, but we did not put the ammeter there, so it was its conduction, electrical conduction. You could even say glowing of the bulb or something like that. So that is like excellent, right? So if it's a conductor, electricity will flow through it. And if it's an insulator, then there's no electricity passing through that specific material. Right, moving forward now, magnetic and non-magnetic substances. So I'm using the acronym SYNC like this, right, to remember this magnetic material. So if it has steel, because steel actually has iron, right? So steel, stainless steel, right? Iron, nickel, and cobalt, right? There is another one, but it's not in your syllabus, so it's fine. So zinc, right? So steel, iron, nickel, and cobalt. Now let's check our examples here. You see steel, yes, neodymium is also on the end, but we don't do it, but I still have it here because we must always strive to know everything and know the most and know the best, okay? And then the reason why I like remembering this SYNC acronym is because so easily we think that every single metal is magnetic, and that is not true. The metal must contain these substances, even if it's in combination, right? Like steel is a combination of iron, it's an alloy, but it's magnetic because iron is there. So you see gold, brass, they're also metals. Copper is also metal. Silver is also, and mercury, but they are non-magnetic because they do not contain these substances here or these elements here. Steel is not an element, but iron, nickel, and cobalt, right? So please always remember zinc. There are other ways you can make any kind of acronym for yourself to remember. Right. So let's quickly look at one appliance and object of how you can apply it. For example, these are earphones or headsets. Now, can you see that in a specific appliance, you can have both the insulator and the conductor? Because inside of these cables, you've got your copper wire, which is your conductor, but outside you've got a PVC, which is your plastic or your electrical insulator. So you must learn when you study this topic, study it with real life applications, because then it becomes so easy. Even if you are given something that you don't know, for example, they give you a picture of an iron, for example, then you know that, okay, the part where we are ironing with, it needs electricity to work. So that would be a conductor of electricity. And the plastic where we are holding is to protect us. So that would be an insulator because we want to insulate ourselves from that dangerous current. So that, I think, summarizes the part for 10 marks. So let's look at questions. Here's a multiple choice. An example of a ferromagnetic substance is, now we know zinc. So zinc has, let me just write it one more time here. Zinc. So that is steel, iron, nickel, or cobalt, right? So iron is Fe, nickel, and cobalt, right? So the correct answer here would be A. These are metals, yes, but they are not magnetic, ferromagnetic. Right, then the next question, I'm actually going to put a timer here for you guys to do it. And I'm only going to give 3 minutes for it, right? So your time then starts now, and then I will reveal the answers here. So it's just from 2.1.1 to 2.5, and your time is ticking. Right, your time is up. So here you were given the different kinds of properties around the material, and then you were given scenarios, and then you have to basically just match the scenario to the options. So we have thermal conductivity, ductile, melting point, magnetic, electrical conductivity, brittle, boiling point, non-magnetic, density, and malleable. So the first one is a hot block of margarine will change its state from solid to runny liquid on a hot day. So that is change of states. Change of states is usually, for example, boiling point or melting point. So you have to choose between those two. A ladder made of aluminium is much easier to carry than steel. So that's in terms of its basic heaviness. And heaviness comes from, I didn't actually touch on that one. It comes on density, which is mass divided by volume. So the heaviness is coming from the mass in kg. Sheet metal pressed to shape car body parts, that is obviously malleability. Then copper and low carbon steel materials are used to manufacture wire, ductability, and aluminium cup containing boiling water, keeping the water warmer for a longer period of time, speaks to heat. So that will be dealing with thermal conductivity. Right, so I know our students love a memo, so I wanted to show the answers and see if you got it correct. So melting point, density, malleable, ductile, and thermal conductivity. Right, so that's how you should be able to apply it in a variety of ways, or in very new situations as well. So yeah, I think that is perfect, and I think you'll be able to get your 10 marks. Now, classification of matter, which I plan to spend the last 30 minutes on, is like also the part of the periodic table, the part of chemistry that most students don't like, and I have no idea why. Right. So 30 marks, it's going to be here defining or define a pure substance as a single type of material, define an element as the simplest type of a pure substance, defining a compound as a substance made up of two or more elements in an exact ratio. Is there any other definition left out there? Okay, I'm not sure, but they are all listed here. And then naming of compounds, cations and anions, molecular formula, and then obviously to name those formula as well, and some aspects of balancing of the equation. So let's get started. Right, so now when we look at the periodic table, on the periodic table are elements. I know you already know them. I'm not even going to show them again. All right. Now, let's take, for example, in group 1, let's take lithium as an example, right? Lithium is Li, all right? That is lithium, okay? Then we also have lithium in its ionic form, right? In its ionic form, right? And then we also have lithium, say, for example, as a compound. So we can have lithium hydroxide as an example here. So it's the same lithium that I'm speaking about, but if you look here, lithium is appearing in three different ways, or in three different outfits, right? So let's check what is number 1, number 2, and number 3. So number 1 is lithium, lithium as an element. Because it is an element, we are saying that the number of protons are equal to the number of electrons. right? Where do you get the number of protons and electrons? It is the smallest number of that element on the periodic table. So lithium, if you go to the periodic table, you'll see it's written 3 and 7, right? So this means that this 3 is the smallest number between these two numbers, right? So this 3 is the number of protons. So I'm saying that it has 3 protons, which are positive, and it has 3 electrons, which are negative, right? So therefore, I'm saying that it is neutral. So we've got 3 ions, right? We've got positive, negative, and neutral ions. So the neutral ions are short in here, which is your neutrons. So how do you get your neutrons? Your neutrons is going to be the mass number, which is the largest number there, minus the smallest number, which is your atomic number. Okay, so this will be 7 minus 3, which means that it's going to have 4 neutrons, and sometimes they abbreviate it like that. Right, so that is lithium as an element. It's neutral, it's got no charge because these neutrons actually are balancing that shortage if there is. So here protons, electrons are equal. But now lithium again, right, here is represented in its ionic form. So this is lithium as an ion. So which kind of ion is it? It's positive. I'm going to write positive. See, pause. Pause are for a cat. Let me even write Katsi. So this is the Katsi of the ions. So it is a cation. It's a positive ion. And that is a cation. Excellent. Now, what makes it a cation means that it's got more protons than it has electrons. So in other words, the proton number always remains the same. The protons are encapsulated in the nucleus. So it's not easy for them to get out. The electrons can move up and down. They can be donated, they can be gained, but not the protons because it is inside of the nucleus, right? Which you already know the atomic structures. Most teachers are teaching this topic using that. So now what we are saying is that lithium will always have 3 protons, always. No matter if it's an ion in a compound or if it's an element. But because it has one more positive here, plus, it means that it only has 2 electrons. Right? So basically now it's a positive ion because it's got one more proton than it has electrons, right? And that is a cation. Then now if we speak about lithium here, inside of this element compound, there are 2 elements, right? Or actually 3, but here we are talking about this part and this part. So what I want you to always remember, right, always, is that the cation is always in the beginning of any kind of compound. So you will always have your cation and your anion. So it's always the positive Katsi comes first, and then you have negative second, right? So here also, this is the lithium cation, right? So it is this one, and this one is the hydroxide, so it is the anion. So you have your hydroxide, and here you've got lithium, which is the lithium ion. It's not an element, right? So this is Li plus. Now, because we are also saying that the element is also, the compound, sorry, is also always neutral, right? So because it is neutral, it means same as the element, the positive and the negative are equal. So if it has a positive lithium ion, then it means that the hydroxide is negative. So whichever compound, I'm going to make more examples now, whichever compound you get, the front part is your positive cation, and then the back part is your negative anion. Now, usually when I'm teaching the topic, I always focus on the anions first because of the fact that in the ATP, they actually list them for you over here. They tell you, right, the sulfate, the sulfite, the carbonate, and the hydroxide. So basically, 1, 2, 3, 4. There's like 4 really to remember. We can make it 6 because of, oxide, which is -2. So yeah, you can make it 5 or 6, but it's much easier to start learning the anions first, and then you know that whichever anion you have, if it's 1 here, it's also 1 positive on the other side. So let's look at more examples. Right, so we are now at the part of compounds, right? And inside of our compounds, we're identifying that it is a cation plus an anion, right? When we have to look at them, okay? So because it's cation and anion, it means that it's made up of 2 or more elements. Right? Definitions, I trust you to go and study them, right? So let's look at different kinds of examples, right? Let's look at copper oxide. Use more grade 12 ones, right? Copper chloride, or before copper chloride, let me go for potassium chloride, sodium chloride, then go to copper 2 chloride. Let's go for water, and then let's go for carbon dioxide and carbon monoxide, right? So these are all compounds. Now, because I told you now this hack that the cation always comes first, it means that the cations are all the ones that I'm going to underline now in blue, right? So all of these ones are our cations, right? So if we have to write the cations here, it's going to be copper, sodium, okay. So now can you see what I've written? I have not written any cation. I have written down the element, and this element is neutral. These are elements. In order for it to be a cation or anion, it has to have the small anion negative or small anion positive, where it can be positive or 2 plus, or it can be 2 minus, you see? So it has to have that like up exponent. So now I said to you, it's easiest to first start with your anions because there are few to remember, right? So if you know your anions, you go and sit and study your anions, you will see that you have oxide, right? Oxide -2. Chloride is -1, right? If I go back and put just duplicate this and bring it down quickly here, and I'll show you a hack afterwards. Right? Chloride. Okay, then again here you see it's still chloride, chloride, chloride. It's still oxide, still oxide, still oxide. So you see what I mean? It's only 2 anions to cram or to study, but and then you can match them. So for example, we know that, okay, the oxide is -2. So -2, it must balance. There must be the same number of negative and positive. So it means then that your copper if your oxide is -2, it means that the copper cation is going to be +2. See? Chloride, we know chloride is -1. So therefore, it means that the potassium is going to be +1 because these must match each other, must equal to 0. So again, here you've got still your chloride. Chloride is always -1, so it means the sodium is going to be 1. Now here you've got 2 chlorides, you see. So the total of them is going to be -2 because there's 2 of them. So it means that this cation must be +2. Now this oxide, we know oxide is -2 always. So it means that now these 2 hydrogen, they must both be plus because you must get them to be equal. I will go to periodic table now, then also another method. Right, then here you've got 2 oxides. So here the total is -4. So this copper will be +4. You see? Then carbon monoxide, sorry, I said copper, carbon. Then this carbon monoxide, oxide is -2, right? So then it means that this carbon will be +2. So if you study your anions, it's always easier because then you can even name them easily because periodic table 1 to 20, most of us know. And then the catch is it's not with your anions, it's when it's O, it's not oxygen, it's oxide. It's not chlorine, it's chloride. So you study your anions, then it becomes so easy because most of us know the periodic table, right? So that is one way. Another way that you can actually study the anions and the cations, or not even study them, just see them because you're always given the periodic table in the exam, right? So this is group 1 and this is group 2, right? So these ones, all of these ones are +1. You see, and we only go up to 20. Then beryllium is +2, magnesium is +2, calcium is +2, you see. So it becomes also easy. Then on this side, this is group 18, right? The last one, they do not react at all, right? Then this one is 17. So 18 minus 1 is 17. So these ones are like -1, you see? And then here, 18 minus 2 is 16, you see. It's not like always, but like, yeah, this is a cool hack for you to know, right? This is 13, 14, 15, right? So even like silicon or even phosphorus, it has 5 here. 5, these ones have 3. You see from 13, these ones 4, 5, you see. So there's so many different ways you can go about and look for yourself, you know, which way do you remember it correctly, but this is a nice way. So this is one way. Group 1s are +1, +2. Then these anions here are -1, you know, 18 minus 1 is 17. Or you can go the way of, you know what, let me just sit down and study my anions. Oxide is -1, chloride is -1, hydroxide, which is OH, is -1. You see, it's up to you how you want to study it, but at the end of the day, you're going to have to know them, right? So these ones are easy examples. I want to now go when it's now more than one. So let's go now. For example, when we have magnesium, right? Magnesium is in group 2 of the periodic table, therefore it is going to be a +2 cation. Now, if I wanted to form magnesium hydroxide, right? That is what I want to form, okay? So magnesium hydroxide is what I want to form, and I know because I studied my anions that this one is -1. Now you see, I want to form, what do I want to form? I'm going to write it in words, magnesium oxide. This is what we want to manufacture. So what did I tell you? I told you that if you've got 2 positive, you also need to have 2 negative. So it means that we're going to have another hydroxide so that we have 2 negatives and we can balance the positive. Now, how do you write it out in stock notation, right? So stock notation, it's going to be Mg, your cation first. Then you have to put a bracket because you want to show that both of them are increasing in number. You see? And then you have to put 2 there. So that is for magnesium hydroxide. If I, oh, sorry, I wrote magnesium. If I want to form magnesium oxide, it's going to be different, right? It's going to be magnesium, which is 2 plus, and oxide, which is 2 minus. Now they are both equal to 2. So how will you write it? Mg, no need for brackets, O. You only put a brackets when you're having 2 capital letters. That's sometimes how I'm also teaching them. So this one is magnesium hydroxide, right? And this one is magnesium oxide. You see, we don't just formulate compounds and write it the way we want to. There's an actual explanation as to why this one is 2 and why that one is 3, right? Let's look at another example. For example, we want to have iron. Iron can be in many forms, right? So I want to have iron 3. I want to have iron 3 oxide, all right? So iron 3 now, they are saying to you that they want to have iron 3 plus cation, right? And we want to have it mixed with an oxide, right? Now you see they are not balanced, okay? So what can we do? If we add now another oxide, it's now -4 and 3. So it means now I still have to add another iron. Now these ions are totaling 6, right? Plus 6. And now my oxygen is short, no? So if I add a third one, now what is it? It's equal. You have got -2, -2, -2, it's giving me -6. And you have got +3, +3, it's giving me +6. It's balanced. Now, how do I write it out? I'm going to write Fe2 because there are 2. And then I have to write O3 because I've got 1, 2, 3. And you have got 1, 2. This is my stock notation. Iron 3 oxide. You see? So let's go to another example now. Let's say, for example, we have let me go for sulfide. So copper sulfate, right? SO4. Okay. Now, if you are studying your anions, this is copper sulfate. Sulfate is also -2. So this whole part is -2. Therefore, this one is going to be a +2 cation, right? So what is the cation? Your cation is copper 2, right? You can't say copper because copper is just Cu, and this is not Cu, this is Cu2 plus. So this one is an element, and this one is our ion, right? You can even be more fancy and write a copper 2 ion. And this here is your sulfate. So what is the name of this compound? It is copper 2 sulfate. And there are tons of examples. You must be ready for knowing your anion And then it's easy now because most of the elements, you know them from the periodic table, right? So which part have I dealt with now? I've basically dealt with an element. I've dealt with a compound, which is made up of two or more elements. For example, here it's actually copper, sulfur, and oxygen, which is making up copper sulfate. And then I've also dealt with the formation of a compound using its anion and its cation. Now, this part that people don't like, yeah, identifying the cations and anions, I've done them. It's easy. Start with your anions, then you start matching them with their cations, right? Then write the name of the compound when a molecular formula is given, and write the molecular formula when the name of compounds is given. Name the compounds using the names of elements which they are made from. So all of those ones, we have done them today, all right? So let me just make another example for you. Right? One like in a similar one from the beginning, right? So here we have this element, not specifying its name. Then we've got this ion, and then we have this element in this compound, right? So let's recap. This one is an element, right? It has equal number of protons and electrons. On the periodic table, it is element number 1. Therefore, it has 1 electron and 1 proton, and its name is hydrogen. Right? Then this one here is an ion. It is a positive ion. Therefore, we are calling it a cation, right? What is its name? It is a hydrogen ion. Then here you've got a compound, right? This compound is made up of two elements. It's made up of hydrogen and oxygen, right? Those are the elements it is made up of. Which ions is it made up of? It is made up of hydrogen ion and what again? Oxide, right? So it is made up of 2 hydrogen ions and 1 oxide. Together, they are forming water. See? So element, ion, and then we have our compound. Right. So I don't have a question here because there are so many. You have to be ready for them. Let me just do a carbonate for you. Example of a carbonate. Right, so let's do calcium carbonate. Calcium carbonate. Right, so this is carbonates. Carbonates are also -2. You'll see most of them are -2. You only have a few that are -1. Your manganate, your chloride, hydroxide, others are mostly -2. Right, so here we have now calcium, and we've got our carbonate, and our carbonate is made up of carbon and oxygen. Right, so here is your calcium. Calcium is in group 2 anyways on the periodic table, so that means it is calcium. And this is your carbonate, so that means your carbonate will be to the power -2, right? That is your carbonate. All right, so that is your compound. Your compound is made up of calcium, right? Your calcium has 20 electrons, 20 protons, and your calcium ion is having 20 protons and 18 electrons. Therefore, it's having 2+. They're short in 2. So that is Ca2+, and that is Ca. So this one is your element, and this one is your cation. And your anion is your carbonate. Right. So, hey, I love this chemistry because it's so like, it's amazing because if you really, really sit down and you study it, it always remains the same. It doesn't matter if it's 2024 grade 10 or 2026 when you're in matric, we're going to be looking at the exact same calcium with its 18 electrons as an ion, and we're going to look at the exact same calcium as an element with its 20 protons and 20 electrons. So if you build your foundation, that was my opening slide, we're building for the future. If you get it correct now and don't do this, they say cram, pass, forget, CPF. Don't do that cramming style. Honestly, go sit down, watch this video recording maybe 2 or 3 times, even the night before or 2 days before the exam on Sunday and Saturday as well. Like, go through it over and over so that you fully understand it, because you never know what is going to be asked. But there are so many ways to answer it if you get the basic foundation, as I've been, or these hacks that I've been discussing today. So from my side, as the last DRP, I thank you very much for your time, patience, and good luck with your examination. Mr. Nambani, over to you.
Thank you very much, President Holt. Thank you, thank you, thank you. I actually loved the FET simulation. It actually makes things easier and more understandable, and I hope our teachers in the near future can basically just use them more for purpose of practicals and so. However, thank you very much, ma'am. I still need to check reflections from the people that are here. Let's quickly start with Mehlaba reflections, please.
Dumelang. Good
Hello, ma'am.
Thank you, President Note, for sharing different methods in terms of balancing of cations and anions. I, as a teacher, learned a different way. I usually use cross method for formation of compounds. And then on the same point where you said phosphorus, can you please kindly go back to the slide where you showed us using the periodic table? I don't know if I was the one who was a bit disturbed, or you mentioned phosphorus as 5.
Yeah, phosphorus is 5. We are actually referring to it as a pentavalent element, especially in grade 12. So we are saying that it has actually 5 electrons to dope with, for example, silicon, and then it will form a negative type semiconductor. So I'm also using that there. 13 is, for example, aluminium, which is trivalent. Then silicon is 4, and phosphorus is 5. So I'm also using that as a hack there from those groups there, because it's pentavalent to tetravalent to trivalent there. But I think that's a bit advanced for the grade 10s, but it was just in my mind while I was presenting. Askisime.
No problem, because I thought I'm the one who's confused as phosphorus as an ion, because it's -3, but you've answered my question. I thought we said that it's a 5 as an ion, not a minus.
No, I was speaking about it as in its valency there.
Okay. No, thank you.
Oh, thank you, Mehlaba.
Thank you, President Holt. Thank you, Mehlaba. Let's go to Memabule reflections, please. Memabule. Okay, let's quickly go to Memo Halamati.
Good afternoon, colleagues. From my side, Mr. Nambani and Me, everything was quite clear. Yeah, I think everything is clear. So I'm just happy, and thank you so much, Me, for the presentation. It was very good. yeah, so everything was just clear for me. So thank you, sir.
Thank you very much. Mariska there by HTS Sassolbeck. Reflections, please.
Good afternoon, colleagues. I have to say that the children really enjoyed this session. They loved it, and I can see that they're very excited to go home and study, which is a very big thing for us. Thank you.
Thank you very much, Mariska. Kindly, guys, colleagues, don't forget to send few pictures, because remember, we are doing it also for the purpose of reporting. And with that being said, ladies and gentlemen, to our kids, our learners, all the best for the examination that is going to be now on Monday, and let's kindly prepare accordingly. The exam will be 150 marks for 3 hours, so take your time. However, just remember also you need now to prepare fully so that you can be in a position of completing in time. Ladies and gentlemen, thank you very much, President Holt. Thank you very much, colleagues. And from myself, all the best, and may the great Lord bless you endlessly. Thank you very much. Have a lovely day.
Lamboni. Job very well done. Thank you, Tate. Thank you. Okay, bye-bye. Yeah, I'm done. Bye.
You'll send the PDF next.
Yo. Ish, thanks for that reminder. Yeah, no, today I was focusing on alternative methods, man. Ish.
Nicely done, President Holt. Very nice.
Thank you, Tate. Let me save this